This is Patrick at OneCNC West, and what we're going to do in this training video is continue to apply toolpath to our solid model using OneCNC Mill Professional. Now to start off with, let's perform a finishing operation on this surface right here. So to do this, we're going to head over to the Command Manager. We're going to select our Model Toolpaths, and we're going to use this toolpath called Planar Finish Face. Now with this machining operation, we can take our cursor and simply select the face that we'd like to apply the toolpath. So I'm going to left click, and then when I'm done, I'm going to right hand mouse click. Now just like with our previous machining operations, the very first dialog box is where we define a tool. And again, you can manually create a tool or you can select a tool from the tool library. In this example, I've already filled out the parameters. The tool is going to be in turret position number 3, RPM 4500, feed rate 30 inches a minute. We're using a ball end mill. It has a flute length of 1 inch 250 thousandths and a diameter of 250 thousandths. All right, that looks good. Let's click next on that. All right, now within our clearances and depths dialog box, we have our rapid Z-plane and our plunge clearance. Remember, the rapid Z-plane is the safety Z level the tool's going to use if it has to reposition from one location to another, and that's defined by this red grid here. That's also dynamically displayed. If I change the value to, let's say, 1 inch, that red grid will hop up there. Let's put that back to 200 thousandths. The plunge clearance, that's where the tool is going to start to feed down, and I think 50 thousandths is fine. So let's click next on that. All right, so the first parameter here is toolpath angle, and over here this kind of gives you an example of that. If you put in a toolpath angle of 0, that's going to be toolpath that's parallel to the x-axis. I want the toolpath to be parallel with the y-axis, and so that's why I've got a toolpath angle of 90 degrees. The zigzag minimum clearance, that's the level that the tool is going to pull up in between each pass. And for this, 200 thousandths is fine. I'm going to say leave for finish 0 because this is going to be a finish pass. We're going to use the default surface tolerance of 2/10, and for the direction, we're going to be using zigzag. Now it's important to note that if I use zigzag, this zigzag minimum clearance is only going to be used at the very beginning of the machining operation. But if I were to use Klein milling or conventional, what's going to happen now is OneCNC is going to use that zigzag minimum clearance in between each individual pass. But because zigzag is one continuous toolpath, the zigzag minimum clearance will only be used once. All right, so for stepover, I've got constant stepover of 50 thousandths. That's the distance in between each pass. I'm going to reduce that to 20 thousandths. I think that looks good. Let's click next on that. Now for boundary type, the only option is part, and the reason for that is because we've already defined what we want to machine earlier when we digitized the surfaces that we wanted to apply the toolpath. For tool placement, you have 3 options. You have outside boundary, none, and inside boundary. Outside boundary means that the tool can travel outside of the boundary, but only until the tool becomes tangent to the boundary. None means that the tool can also go past the boundary, but only until the center line of tool reaches the boundary. And inside boundary means the tool has to stay inside the boundary up until the tool becomes tangent to the boundary. I'm going to use none for this. Now down here in the lower right hand corner, this controls the amount of toolpath along the z-axis. Let me explain how this works. If we were to use the automatic Z option, and in this example we have 50 thousandths, OneCNC is going to scan the solid model. It's going to add 50 thousandths to the top, 50 thousandths to the bottom, and that's going to be the Z envelope in which the toolpath is going to be constrained. Now you can uncheck this and you can type in whatever values you want. You could say that I want the toolpath to be constrained from, let's say, Z0, and let's say for Z bottom something like, how about minus 880 thousandths. So we'll click Finished on that and let OneCNC generate the toolpath. Why don't we now take a look and preview the toolpath? To do this, we're going to head over to the NC Manager. I'm going to right-hand mouse click on the toolpath group, and I'm going to select Preview Toolpath. Now, Preview Toolpath is a great way to see how the tools interact with the geometry. Now, you're not going to be seeing material being removed when you preview toolpath, but again, it's a great way to see the association between the toolpath and the part geometry. In the lower left-hand corner, you have a speed control. If you move the slider to the right, the preview will speed up. If you move the slider to the left, the preview will slow down. You can also step forward and step backwards as well. Now, if you look at the toolpath colors, the green toolpath, those are feed moves. The blue toolpath, those are high feed moves. And the red toolpath, those are rapid moves. In fact, every time the tool turns red, that is a rapid move. So toolpath preview is an excellent way to see the relationship between the toolpath and the part geometry. Let's take a look at toolpath simulation now. Simulating toolpath is different in that you're going to be able to see the stock material being removed. We start exactly the same way. We head back up to the toolpath group, right-hand mouse click, but this time, instead of selecting preview toolpaths, we're going to select simulate rest. Now for this, we have three different options to define the stock. There's extents, there's stock model. Stock model is using the solid model we created a little earlier in a previous video that's located on this layer called stock. And if you use pick boundary, that means we're going to be selecting a 2D wireframe boundary to define the shape of the stock. For this, why don't we use stock model? I'm going to go ahead and click that. And from there, we're going to click OK, and we'll let OneCNC simulate the toolpath. So what we're seeing here is the very first tool, and indeed you can see stock being removed. In the upper right-hand corner, you can see the coordinates specifying the location of the tool. Lower left-hand corner, we have our speed control again. This is our little slider. We can move it to the right to speed it up, move it to the left to slow it down. There's also other parameters on the left-hand side that are very useful. For example, we can make the tool holder translucent. We can hide the tool holder. We can do the same with the tool as well, make it translucent or completely hide it. You also have the ability to show backplot. That shows you the toolpath. You can turn that on and off. And all during the simulation, you can rotate the view if you'd like. You can also zoom in and zoom out, and you can pan as well. So what we're looking at here is that planar finish face machining operation. And remember, we set the toolpath to 90 degrees, and that's why that toolpath is parallel to the y-axis. All right, very good. Now let's exit out of the toolpath simulation and continue to apply our toolpath. Why don't we take a look at machining this area of the solid model, this wall. Now to do that, we're going to be using the Z-level finish machining operation. And I think we should probably create a boundary to help contain the toolpath because we don't really need it to finish all the way around the outside of the part. I'm going to hit the spacebar twice to go into a CAD view. That looks good. Let's quickly head over to the command manager and go into our line and then rectangle tool. You can use coordinates, but I'm just going to grid point snap this. I'm going to move my cursor right about here and left click, and I'm going to pull the rectangle up, and I'm going to place it right about here. Let's move it up a little bit more in Y. I think that looks good, so we'll left click that. All right, so we're going to be using that rectangle as the boundary to help contain our Z-level finish command. Let's go back into our model toolpaths and select Z-level finish. Now I'm going to be using the exact same tool we used earlier within our planar finish face machining operation. So I'm going to leave all these parameters exactly the same. 1/4 inch ball nose end mill, speeds and feeds identical. Let's click next to that. Our clearances and depths look good. We have 200 thousandths for the rapid Z plane, 50 thousandths for where the tool is going to start to feed down. I think that looks good, so let's click next on that. For approach style, we have three different options. Now we have vertical approach. This is where the tool is going to feed down, engage the part, and then perform its depth of cut. We have radial approach. That's where the tool is going to arc on, perform its depth of cut, and then arc off. And then we have ramp boundary. That's where the tool is going to ramp down and then perform its depth of cut. For this, I'm going to be using radial approach. Now for the radial radius, I'm going to use 200,000. I also want to make sure I have this option selected called Pick Faces to Avoid for finishing. And the reason for that is I don't need the toolpath to try to finish this face that we've already machined using our planar finish face operation. We're going to be climb cutting. Let's click next on that. For this, I'm going to be using constant depths with a depth of cut at 20 thousandths. I'm going to leave 0 for finish because this is a finish pass. And for tolerance, we'll use the default of 2/10. That looks very good, so let's click next on that. This is where we can specify additional depths of cut. We don't need to do this for this toolpath, but it is a very powerful option. We're going to click next on this. For boundary type, we have a couple of different options. We have Extensbox and Picked. We want to use Picked because we want to pick that rectangular boundary we just created. For tool placement, just like with planar finish face, you have 3 options: outside boundary, none, and inside. For this, I'm going to be using none. In regards to containing the toolpath along the Z-axis, I'm not going to use automatic Z. I'm going to uncheck this, and for Z top, I'm going to type in 0, and for Z bottom, I'm going to type in minus 880 thousandths. Very good. Let's click finish on that. Now it's time to select that rectangular boundary we just created. I'm going to left click that and then right hand mouse click. Now it's time to select the faces that I want the toolpath to ignore. I don't want this toolpath to remachine this face. I'm going to left click that, and when we're done, we can right hand mouse click and let OneCNC generate the toolpath. Excellent. Now this toolpath looks good, but we can do much better. If I rotate the view just a little bit and left click on the machining operation, you're going to notice that the toolpath cuts down inside of that cutout. We really don't need that to happen. So what we're going to do is we're going to create a surface to help cap this cutout and therefore keep the toolpath from going down inside there. We can quickly create the surface by heading over into the command manager and selecting our model tools, and from there we're going to use this option called extract an edge. I'm going to take my cursor and left click, and when we're done we can right hand mouse click. Now to show you the geometry we just created, I'm going to hit the letter S on the keyboard, I'm going to left click, and then hit the letter B on the keyboard to hide or blank the geometry. The blank command is also located up here as well, but I'm just going to hit the letter B on the keyboard, and you can now see the geometry we just extracted. Now I want to make this a closed boundary, so I'm going to use our line tool. I'm going to take my cursor, I'm going to left click, and when we're done, we're going to right hand mouse click. Let's bring back our solid model by hitting the escape key on the keyboard and just left click on our layer. That looks good. And now let's create that capped surface. We'll head back over to the command manager, go into our surface tools, and select the option called surface from curves. Now we can take our cursor, hover over the boundary we just created, left click, and then right hand mouse click. Very good, and all we need to do now is edit our machining operation so that we're ignoring not only this face, but also this new surface as well. We can do that by right hand mouse clicking and select repick path. We don't need to change any of these operations here, so we can just click next all the way through, and then we'll click finish, and then when it says would you like to repick the boundary, we're going to say no to that, and now we have the opportunity to select those surfaces, those faces that we'd like to ignore. So I'm going to left click, and now I'm going to right click and let OneCNC generate the toolpath. That looks much better, and now you can see the toolpath has not cut down inside of that cutout. Why don't we end the video by performing a toolpath simulation? Let's head back over to the NC Manager. We're going to right hand mouse click on our toolpath group. We're going to select Simulate Rest, and just like before, we're going to use the solid model on the stock layer for our stock, so we'll use Stock Model. We'll click OK and let OneCNC simulate the toolpath. Now, within the toolpath simulation, we're looking at the very first tool performing that Z-level rough machining operation. We're taking 150 thousandths depth of cut, and we're leaving 20 thousandths on the side of the part. Now we're performing a profile operation right there, and now we're going to use a 1/4 inch diameter ball end mill to perform that planar finish face machining operation. We're taking a 20 thousandths step over, and also remember that we used 90 degrees for the angle to make sure that the toolpath is parallel to the Y-axis. Now we're going to be using the exact same tool to perform the Z-level finish machining operation. And that's what we're seeing right here. We're taking 20 thousandths depth of cut, and because we created that cap surface, that's going to prohibit the tool from machining inside of that cutout. Now, it should also be noted that you can use cap surfaces like the one we created, or you can use modified boundaries to help contain the toolpath and place it exactly where you want. Alright, that's it for this video. Thank you so much for watching, and I look forward to seeing you in the next video.